Howdy and good day, fellers. Today in Algebra, we'll be going over the answers to CO15, solving multi-step inequalities. Like we talked about, these are the process for these is the same as an equation. So if you struggled with the distribution, with the combining like terms, variables on both sides, PO10 was kind of where I direct you to. And we only care it's an inequality that those final couple steps when we divide by the coefficient, in case we have to flip it, and then when we graph it. So looking at the answers on this first section here, which two did we do together? The two on the left?
Yeah.
Okay. So the two on the right, that 8 times 3n minus 4, we need to distribute there. And so that's going to give us 24n minus 32 is greater than or equal to negative 80. Add 32 to both sides. 24n is greater than or equal to negative 48. Divide by 24, and we get n is greater than or equal to negative 2. No need to flip our symbol here because that 24 is positive. And so negative 2, closed circle, going to the right. Yay?
Yay.
Okay, questions on that one? The one below it, combining like terms, we've got 16 n's and negative 11 n's on the same side. We can combine those to just be positive 5 n's. 16 minus 11. And that's less than or equal to 49. Subtract 4 from both sides. 5n is less than or equal to 45. Divide by 5, and we get n is less than or equal to 9. Graphing that, closed circle at 9. Going to the left. Yay? Yay. Questions? Nay. All right. The one down at the bottom, that next section you needed to do here, with the no solutions or infinite solutions, we did the first two together, which left you with that last one. What did you come up with? Infinite. Why infinite? What was, Gabby? Right. Yep, so our first step here is to distribute that 3 so we can get a better picture of exactly what we're dealing with. And we've got 12 n's on both sides of the inequality symbol. Okay, so 12n on the left will cancel out with 12 n's on the right. And that leaves us with the statement 18 is greater than negative 19. Where you may have gone wrong here is if you forgot to bring down that negative sign. And you saw 18 is greater than 19, which isn't true. However, 18 is greater than negative 19, which is what you should have. And therefore, it's the infinite solutions or all solutions or the double-stemmed R, whatever you want to see there. Okay? Questions on that one? All right. We are cruising. Excellent.
Yay.
Yay, indeed. Second page, we did a couple of these together. Did we do the first one? I don't remember either. I'll just do all of them. So this first one, the thing to avoid was right off the bat subtracting 18 and 2 to get a coefficient of 16. That's going to be a problem because that would mean you subtracted before you multiplied. So your first step is to distribute the negative 2. We get 18 plus 14n minus 6 is less than negative 2. Now we can combine our 18 and negative 6 to get 12 plus 14n is less than negative 2. Subtract 12 from both sides. 14n is less than negative 14. Divide by 14, and n is less than negative 1. Don't flip our sign. Open circle at negative 1 going left. Soybean. Instead of what? Yeah, so looking at the signs of these, we have a positive 18 and a negative 6. 18 minus 6 being positive 12. It's going to be a positive 12 when we combine those terms. Okay. Did you use opposite operations by chance? If you did, you wouldn't use opposite operations here because you're not moving from one side to the other. You're combining on the same side. So the operations aren't going to change. Anything else with that one? Okay, the one straight across from it, we've got 2 sets of parentheses, so we're distributing twice. 5n plus 15 is greater than negative 2n plus 92. Check your sign on that 92 there. Negative 2 times negative 46. It's going to behoove us, because we have a choice here, right? Variables on both sides. We can either move our 5n's over to the right or move our negative 2n's over to the left. Which one's going to serve us better? Make our lives a bit easier. Gabby? I would move our negative 2n's over to the left, right? That does two things for us. First of all, it keeps this coefficient that will ultimately be dividing by positive, so we don't have to worry about flipping the sign. And it also keeps our variable on the left, which although it's okay for the variable to be on the right side, it's kind of, I don't know, more typical and therefore easier if it's on the left side. We'll subtract 15 from both sides as well, move that over to the right side, and so we get a 77 there. So why did I write plus 15? I don't know. Jumped ahead. So we get 7n is greater than 77. Divide both sides by 7, and n is greater than 11, which is an open circle at 11, going to the right. Things going okay? Okay. Just in kind of order to speed up things a little bit here, I'm just going to write the answers, and then if you want to talk about the process to get there, then we can take a look at more deep into that. So the next one, we get n is, no solution. The reason why is when you distribute, you get negative 24 n's on both sides, and then our inequality that we get is not true. So no solution there. The fourth one, we get n is greater than negative 1. So open circle at negative 1 going to the right. Any issues with either of those? Want to discuss? The question was brought up in the last class, and I don't remember if we talked about this specifically or not, but in this, we talked about our first step would be to multiply by 6 to unfractionalize that. Why wouldn't we subtract 10? Because typically, we start with our constant. Why would it be mathematically incorrect to start by subtracting 10? Yeah. Tell me more. Yeah, it's not written. Go ahead, Elise. Right. Very good. It's not written, but when you've got a fraction, anything that's in the numerator and the denominator, it's as if there are parentheses around each section. Because if we wrote this horizontally, so not as a fraction, 2n plus 10 divided by 6, without parentheses here, that's not what this fraction is telling us. Okay? Writing it horizontally, we do need parentheses to show that we are dividing that sum by 6, but as a fraction, they're just kind of implied. Okay? So whereas if you were solving it horizontally, your first step would be to multiply by 6 to cancel it out. Same thing that we're doing there. Right? Yeah. Sorry? 7. Did you multiply by 6 first? And so that should give you 2n plus 10 is greater than 24. Okay. So 2n is greater than 14. And n is greater than 7. Oh. Negative 1 is the answer to the bottom one. Thanks. How come it took like 2.5 minutes for someone to tell me I got the answer wrong?
Because we all thought we got it wrong. You trust the math teacher.
You trust the math teacher. That's your first mistake. Yeah. N is greater than 7. So greater than, open circle going to the right. Thank you. Thank you. Negative 1 is the answer to the bottom one. Whew. It's embarrassing. Times like this, I wish I knew how to edit these, but I just don't. So there you go. Yeah, that's true. Only like 3 people watch these anyway, so I guess not there you go. Okay. I can see. I can't see who, but just the number. Okay. Going on to the last row here. We already know that sixth one and is greater than negative 1. I think we did this one in class yesterday. Or maybe it was 8cc. But yeah, the trick was you want it to be an all reals or no solution because you see that you have the same number of ends on the same side, except for when you distribute here, it gives you negative 7n versus positive. So the answer is n is greater than negative 1. Open circle going to the right. And this one, n is greater than or equal to negative 3. So close circle at negative 3 going to the right there as well. This one was the only one where you kind of had to flip your sign. The other ones, variables on both sides, you can kind of pick and choose as far as where you moved your ends. But this one, the way it was set up, definitely a sign flippage required. Flippage. Unfractionalized flippage. I'm just full of new vocabulary. Any questions on these 6? Okay. The 2 word problems. So what inequality did you set up here? Who would like to share the inequality that they set up? Someone new to the conversation? Lauren. Sorry, I couldn't. 2.5? 2.15. Okay. Excellent. Okay. 2.15g plus 7.50 is less than or equal to 20. This less than or equal to 20 represents this phrase here without spending more than 20. So it's going to be 20 or below. The 750 represents the car wash. And why is that a constant? Why is the 750 our constant in this inequality? Debbie? It's an unchanging fee, right? The car wash is the car wash. It's $7.50 regardless of how many gallons of gas you get. And the 2.15 comes from the original price per gallon, but a car wash purchaser gets 10 cents off per gallon. Okay, so if you get 75 gallons of gas, your car wash is essentially free. What a deal, right? So you'd subtract that 10 cents from the 2.25, you get $2.15. Solving this, 2.15g is less than or equal to 1250. Start by subtracting 750 from both sides. Divide by 2.15 and you get 5.82, 881, something like that. Okay. In CO14, we talked about a few circumstances where a decimal answer wouldn't make any sense, right? The ornaments and the number of songs. How about here with a gallon of gas? Does a decimal answer make sense? Yes, because you can pump 0.81 of a gallon. So you would not round here. You'd keep your 5.81, close circle, and going to the left. But probably the biggest thing that maybe threw people off was this 10 cents discount and getting this number correct. You wouldn't subtract 10 cents after everything's done. You would do it right off the bat because you're paying $2.25 per gallon. Take that 10 cents off, get $2.15. The next one, saving money for a summer camp. Elise, please. Okay. So yours might look a little bit different. Maybe you put your 14 x first. Maybe didn't use x. Maybe use w or y or n or whatever. As long as you have the 14 connected to a variable and you're adding 500 or a positive 500 and then you're greater than or equal to 800, then you're good. Okay? Because what this is saying is that you already saved that 500. That's a constant. That's done. Right? You'll be subtracting that from the 1800 to calculate how much money you would need to save each week to get the remaining balance, which is 1300. Okay? Divide that by 14, which is the number of weeks. And if my memory serves me correctly, it's $92.87. Okay? You would round to nearest hundredth here since it's money, and that's out of pennies. So if you round it up to $92.90, it's better to round to the hundredth when you're talking about pennies. So what this means is that if you save exactly that amount, that's the least amount you could save, each week you'll end up reaching your $1,800 goal. Of course, if you put more than that away, then that means that a week further on down the line, you wouldn't have to save quite as much. But the bare minimum will be $92.87. Questions on anything with CO15? Okay. Does it make greater than sense than it did yesterday?
No. No.
Was my grammar greater than correct? I don't know. Okay. CO16. So we prefaced CO16 earlier. But before we dive into this, I should also say, if you are looking for more practice with CO15, maybe you got only half of them correct and you're just not quite there with your confidence, there are two places that you can go to. Either look at the top of CO15, and in this literal text box, that's the chapter and section in the textbook that you can look for more explanation, more examples. So chapter 6, section 3. Or you can go to the back of your binder and start doing the practice work. Right? At this point, it's not required because you haven't taken the test yet. But if you want more examples of what the test is going to look like, that practice work will give you 6 more things that you can just kind of play around with. So 2 places to look for extra help should you need it. So CO16, we prefaced this before talking about that inequalities actually have like a beginning and an end. You know, if you go to Target with the intention of spending less than $20, technically the inequality n is less than 20 includes negative numbers, right? You can't go into Target and spend a negative amount of money. That doesn't make any sense. You can gain a negative amount, I suppose, subtraction, yeah. So the other end to this would actually be like $0, right? The amount of money you can spend at a Target, it would be more correct to say it's between 0 and 20. And that's kind of the idea that we're going to tackle today with what are called compound inequalities, okay? And we're going to use water temperatures as a prime example here. So test your science knowledge here. At what temperatures is water a liquid? At what temperatures is water a liquid? Lucas? 33 degrees and higher. So our like 32.1 is that liquid there? You know, so it might be best to say that the temperature is greater than 32 degrees, because at 32 degrees it freezes. Okay. Is there a maximum to this range here?
I don't know what the number is. It's like there's a boiling point.
There's a boiling point when water turns to steam. Does anyone know what that temperature is? 212. Okay. So the water temperature here is an example of where there's kind of like a low end and a high end. Just saying that temperature or water that is warmer than 32 degrees will be a liquid isn't good enough. Because at some point, you keep getting warmer and warmer and warmer, it turns to steam. It's no longer in liquid form. So to show this on a graph, what we would do is we would make our number line, okay? And this time, instead of having just one kind of solution number here, we're going to have 2 of them, because there are 2 temperatures at which the state of water changes, 32 and 212. Okay? Now, if we're looking at the temperatures, water is a liquid at 32 degrees. Is it going to be an open circle or a closed circle? Open circle. Because at 32, it's not a liquid. At 32, it turns to ice. And the roads get very interesting. Okay? How about at 212? Open circle or closed circle? Open. Because at 212, it turns to steam, and you know that your pot of water is ready for your macaroni and cheese. Right? Yeah. And then to show that the range of temperatures that water could be as a liquid, we're going to be connecting those 2 values. Right, it's not an arrow.
The second-
Because the range of temperatures for which water is a liquid does not go on forever. Okay, it's got a beginning point and an end point. Geometry, folks, this is kind of like a segment, isn't it? Okay. What about the temperatures at which water is not a liquid? Okay, when it's not a liquid, it's either ice or it is steam. Okay, what temperatures would water at the ice? Yes. And it's actually going to be less than or equal to 32, right? Because if we put an open circle at 32 for when it's not a liquid, then what is it at 32 degrees, right? If both of our graphs are open circle at 32, that leaves 32 as being, I don't know what, okay? And then for steam, it's greater than or equal to 212, okay? So on a graph, we again have our 32, and we have our 212. If the temperature for ice is less than or equal to 32, we have a closed circle at 32 going to the left. And I know there's something called absolute zero, the absolute coldest it can get, or whatever else. We're not diving that deep into these things, Kelvin, whatever it is. Okay? But right? And then for steam, the temperature is greater than or equal to 212. So if you look at the two graphs that we have here, is there any temperature that's not represented? No. I mean, the graph on the right has greater than or equal to 32 and everything below, as well as 212 and everything above. The graph on the left has all the other temperatures in between them. What type of graph or what type of compound inequality is this one? An and or an or? Say the other one. It's an and, okay? And the reason why it's an and is because there are two conditions that must be true. In order for water to not be a liquid, in order for water to be a liquid, it must be greater than 32 and less than 212. Okay, very good. Your process of elimination. That was some deductive reasoning there. Okay, the other one's going to be an or. Because for water to not be a liquid, one or the other must be true. It must be 32 or below, or 212 and above. Okay, so the difference between an and an or statement, an and statement has two conditions that must be met. An or statement is one or the other. Make sense? Is this the review realm? You've talked about this before? Okay. Bridget, yeah. It will be. Yes. Yes. Okay. It's on this. Yes.
Well, not everything that's on the homework is on the test.
I mean, maybe not exactly, but okay. So what you're going to see on your test, as far as the more numerical, is something like this: negative 11 is less than x is less than 14. Which type of graph is this inequality going to have? An and statement or an or statement? Why is it going to be an and statement? Because it doesn't say or, right? It's easy to see, if it's an or statement, you literally have the word or smacked in there. But what this is saying here is that x is between negative 11 and 14. It's kind of like if we combined the inequalities, negative 11 is less than x, and x is less than 14. Put those things together, and x is going to be in between them. Okay? So the graph of this are two solution numbers, negative 11 and 14. What types of circles are going to be above each of them? Open circles. And being an and statement, our value for x is going to be in between. They're going to be connected. x has to be greater than negative 11, which remember, the left half of this, negative 11 is less than x, is the same thing as saying x is greater than negative 11, right? So it's going to be on the right side of negative 11, and it's going to be less than 14. Two conditions must be met. Daniel.
How do you want to show our wants to write both ways to write like -11?
No, for these, if there is work required to solve them, which for this first one there isn't, all I need to see is the graph. Okay. On this third one, though, there's some work to be done, right? Because what this is saying is that the value of x minus 3 is between 18 and 32. We want to figure out what values for x are going to make that true. So just like any other equation or inequality, to get x by itself, we're using opposite operations. We are going to add 3 to the expression x minus 3 to cancel it out and get x by itself. But we also have to add 3 to both ends, both the 18 and the 32. So our range becomes 18 plus 3, which is 21. Is that still a thing? Okay. 21 is less than or equal to x, which is less than 32 plus 3, which is 35. Okay? So think about an and statement as kind of having 3 parts to it. It's got the middle part where the variable is, and then the endpoint on either side. Using opposite operations to get the variable by itself, you still need to add 3 or whatever the operation is to both sides, both parts. So the graph of this, we have 21 and 35. What type of circle above 21? Closed? Because of that less than or equal to sign. How about above the 35? Open. And we are connecting. Okay? Meaning that any value within this range from 21 to 35, when you subtract 3 from it, it's going to be between 18 and 32. Okay? Those are the values that x can be. So when you did this last year, did you do more with the verbal stuff?
We didn't do this last year.
Didn't we? No. You didn't do this last year? Who told me that you had done these before?
We said that we've done like the one before, like the graph.
Oh, but this is new?
Yeah.
And you're getting it all this well? Wow. Well, I mean, no, for the first time seeing this, you're jumping onto it rather quickly. I thought that there was okay. So let's look at the third type of and statement here, which would be the one in the middle in the bottom row. And again, you can tell it's an and statement because it doesn't have that word or in it, right? We've got 12 is less than or equal to negative 2x plus 2 is less than or equal to 20. Okay? And what this is saying is that expression, negative 2x plus 2, is between 12 and 20 on the number line. We want to figure out what value for x makes negative 2x plus 2 between 12 and 20 on the number line. So what are we going to do first? Here. Lauren. Subtract 2. And when we do this, we subtract 2 from all 3 parts. Right? To cancel it out in the middle, but it also affects the other endpoints. So we now have 10 is less than or equal to negative 2x, which is less than or equal to 18. Now what?
Oh.
Yes. Divide by negative 2.
But doesn't that mean it's
Very good. Yes, that rule of flipping the sign when you multiply or divide by a negative number is true for any inequality, including what we're doing here. So when we divide by negative 2, that actually causes our signs to become greater than or equal to. And so we get negative 5 is greater than or equal to x, which is greater than or equal to negative 9. Now, what's kind of funny about that inequality statement that we have there, Elise?
You can put it like on the graph. Like you don't put the 5 like first.
Right. When you put it on the graph, we would not put our negative 5 on the left or negative 9 on the right, because that's backwards, right?
Negative.
Why is it backwards?
Minus math go the other way.
But why did it? I mean, it started out right? It started out 12 and 20 in the right spot. Why did it flip on us, Lauren? We'll get to that in just a second here. Why did this? Because it started out correctly with 12 and 20 in the right places, but why did it flip on us, Gabby?
When you have a negative number, the higher numbers are behind the lower numbers.
I mean, we had a negative number here with negative 11 and 14, and those were in the right place.
They're both negative.
Not that they're both negative. It's because, Noah? Because we divided by that negative number. In this case, what it causes to happen here, the reason why we have to flip our signs is because it's going to kind of flip the side of our number line as well. Sorry. Okay. So just pay attention to that your final graphing statement here, you may need to reverse those numbers to make that number line fit. We have closed circles above each of them on our values between negative 9 and negative 5. Okay. Now the question was asked, how do we check this? Any thoughts on how we would go about checking this? Brent?
Figure out the number for x and see if it fits in the
What do you want x to be, Brent?
negative 7.
Negative 7. So Brent's choosing negative 7, which is smack dab in the middle of our solution set here. So if we plug in negative 7 to the original inequality, it should work. So we've got 12 is less than or equal to negative 2 times negative 7, replace x with negative 7, plus 2 is less than or equal to 20. We get 12, negative 2 times negative 7 is 14, plus 2 is 16. Is 16 between 12 and 20? Yes, it is. So it works. Okay. If you had picked a number outside of the range, if you had used 0, which is over here, right? You'd plug that in, and it would be outside of the range of 12 and 20, so it wouldn't work. Okay, same kind of thing as two-step inequalities or multi-step. Yeah. The ORs. Any more questions?
This or that.
Yes. Yes, you should check your work for all of them. Yeah. And in fact, I'm gonna kind of do an audible here. Let's save the ORs for tomorrow, and your homework for tomorrow is going to be the AND statements on the second page. If you already did them, then there's no homework for you. So the AND statements on the second page are looks like just these first 3. Okay. The word problems at the bottom. Let's see. This one is an AND. Ooh. Oh, it's fine. And we'll save the brain buster for, so just the first word problem tomorrow. So all the AND statements for tomorrow, get practice with those. And tomorrow we'll cover the ORs and wrap up CO16. Okay. So especially given it's your first time seeing this, and again, you folks, I mean, just first impressions from my point of view are doing very, very, very well. But any questions that you have about the and statements? Just remember that when you're using operations, do it to all three parts of the and statements, that middle and the two outsides. And if you do end up dividing by a negative number, which you will in the three that you need to do for tomorrow, make sure those signs are flipped. Okay? You've got 6 minutes to work before we head to music, so that is how you math.